Charles here. 2022. This is set one, by the way. Set one, 2022. Question number 2. Assume that commercial banks must hold a minimum of 20% of their deposits as reserves. Now suppose that the central bank of the country sells 100,000 of government bonds to commercial banks. First of all, they're telling you that your RRR, or your required reserve ratio, is 20%. We should just go ahead and do this in our head, even if we don't use it. You recognize that to find the money multiplier, it's 1 over the RRR, 1 over 0.2, 1 over 0.2 is 5. This is our money multiplier. You do need it in this instance, but you should just be able to do that in your head very quickly. The Fed is selling, the central bank, the Fed is selling bonds. Anytime they sell, there's a sale of bonds. That's contractionary monetary policy. So sale of bonds is going to decrease the money supply. We should recognize that that change in the money supply is pretty easily just represented by us just saying that. They are looking for a maximum change, or they want us to calculate it. We recognize that that whole $100,000 is going to come out of the banking system because those banks are buying bonds, 100,000 of bonds from the Fed. So that whole $100,000 is money that these banks are going to spend to buy bonds. So they buy the bonds, the money goes to the Fed. That 100,000 leaves the banking system. We'll take the 100,000 times the money multiplier, and that's going to give us a decrease in the money supply of $500,000. All right, they want us to draw for B a correctly labeled graph of the money market. They want to get us a correctly labeled graph of the money market showing that change in the money supply. Give me a sorry, people calling me. Easy enough. We're just going to simply draw our money market graph. We know the money supply is going down, so we can simply show that as MS1 and MS2. We've got a demand for money curve. Some teachers call this your money demand or demand for money. Either way is perfectly fine. They're giving you what's on the vertical interest rate, the nominal interest rate, or sorry, on the vertical axis is the nominal interest rate. This is our quantity of money down here on the horizontal. Let's do this QM1, QM2, show some arrows. I also always want to show what's going on with that nominal interest rate. Draw some arrows. This could be NRI1, NIR2. You probably could have got away with just IR1 and IR2 or R1 and R2, but this has to be nominal interest rate up there to get the points. I think our graph is golden. We're good. Now, given the change in the money supply in part A, if the velocity of money is constant, what will happen to nominal GDP? First of all, we know what's going on here. So if they were going to question me about nominal GDP, I would want to start from when the money supply goes down. This is going to drive up nominal interest rates. We can see that nominal interest rates are going up. I know that's going to make investment go down. Higher interest rates mean people take out less loan, they build less stuff, investment goes down. Aggregate demand goes down. If aggregate demand goes down, price level goes down. If price level goes down and if aggregate demand goes down, real GDP has to go down also. If real GDP is going down, I can be pretty sure nominal GDP is falling also. Recognize that back from when you were doing GDP and CPI, that first after supply and demand, you probably did GDP and CPI units. To find nominal GDP is just price times quantity. Do you remember that? So what we recognize is if the price level's going down, then nominal GDP has to be going down also, right? So this should have at least given us the answer. Maybe you might have not got the point for explaining it. They explain this slightly different. This would have been my first response, but they wanted you to use the theory of exchange formula here. M times V equals P times Q. Sometimes people do P times R. Doesn't matter. This is your money supply here. This is the velocity of money for the V. P stands for the price level, and the Q stands for real GDP. Recognize that both sides of this represent nominal GDP. This is an identity. Both sides have to equal each other. So if this side changed, that side has to change also. Here they're telling us, or we know, money supply is going down while velocity of money is unchanged. Well, if this side falls, this side has to fall also. You simply could have explained by giving them the formula of the theory of value, or money theory of value. I think I'm saying that correctly. I probably messed it up. Brain fart. Anyway, the velocity of money is constant. I know money supply is going down. I know nominal GDP has to fall, mainly because I know price level is going to fall. Easy enough. D says based on the change in nominal GDP. In part C, what happens to the price level if real GDP is constant? Now, there's no explanation here. You simply knew that price level went down, right? That could have been enough to get you the points. But think about it from what we just talked about with this formula of exchange here. If this is M times V equals P times Q, again, this is real GDP right here. This is price level, this is velocity, and this is money supply. What you and I know is that these two sides always have to be the same number. Money supply goes down and velocity doesn't change. Real GDP doesn't change. If this money supply goes down, we can be sure that, and real GDP didn't change, we can be sure that price level had to go down. We can see that and be able to answer that accordingly. All right, guys, take care. Be safe. If you need any help, I'm on Wisant, Charles W. Keep working hard and leave me a message. Let me know if I can do something for you, help you out. All right, be safe. Take care.